This video is on solving quadratics by using the quadratic formula. We're just going to do some example problems. We're going to solve the following using the quadratic formula. It tells us to use quadratic formula. We're going to write our answers in simplified radical form. Sometimes we'll have rational answers, which we do not have to have a radical left over. Irrational answers will have radicals, and we might have imaginary solutions, which might still have radicals left over. So we're going to write out the quadratic formula so that we remember to use it. X equals negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. Just remember that all over does not extend to the x. It has to go from the negative all the way to the end of the radical. I'm going to zoom in on problems. So we have to remember to get our problems into standard form. It needs to be ax squared, bx, and c. So this first problem, our x squared is fine. It's a positive x squared. We need our bx term, which is on this side, which is not good, so we have to subtract that 4x. And then we need our c value, which is a positive 6, and now it's equal to 0. Our a value is equal to that positive 1. Our b value is equal to a negative 4. And our c value is equal to a positive 6. Now I'm going to plug these into the quadratic formula all at once. So we got to remember to use parentheses. Use parentheses when you plug in a number in for a letter, especially when you have negatives because of that squared part. If you don't put parentheses around that, you will not actually get the correct value for your discriminant. So x equals negative, parentheses, your b value is negative 4, parentheses, plus or minus the square root of parentheses, negative 4, parentheses squared, minus 4, parentheses, 1, parentheses, parentheses, 6, parentheses. All of this is over 2, parentheses, 1, parentheses. Now we're going to go ahead and fix the first part and the denominator. So x is equal to a negative times negative 4 is a positive 4. Plus or minus the square root of something we're going to figure out a discriminant. All of this is over 2 times 1 is 2. So again, we're going to figure out a discriminant using our calculator. You can do this by hand, but it is simpler just to put into your calculator. So I'm going to put in the radicand into the calculator. So we have parentheses, negative 4, parentheses squared, minus 4, parentheses, 1, parentheses, parentheses, 6, close parentheses. Again, we don't put the square root because we're just finding the discriminant. This is equal to a negative 8. So the discriminant is negative 8. It's negative. That actually tells us we're going to have two imaginary solutions. So we will have an I have to be brought out. So I'm just going to rewrite this. This is 4 plus or minus. We still have all over the 2. Now, we have to simplify the square root of negative 8. The square root of negative 8, so we know we're going to have an I brought out. So we're going to go ahead and put our I here. Then we have the square root of 8. The square root of 8 is 2 square root of 2. If we remember, this is really just 4 times 2. The square root of 4 is 2. That comes out with the I. And then we have the square root of 2 left over. So it's okay to still have a radical left over. But now we need to simplify as much as possible. So I'm gonna extend that. So I'm gonna separate these into 2 fractions. So this is really 4 over 2. And then we have the plus or minus. Then we have the 2i square root of 2 over 2. 4 over 2 simplifies to be 2 plus or minus. 2i over 2 simplifies to just be 1i, but the square root of 2 has to stay on our answer. This has to stay on our answer because that cannot simplify. This is a radicand, this is not. So these cannot simplify together. Only the coefficients are allowed to simplify. So because we still have a radical left over, we want to actually keep our answer as one set together. So we're going to have x is equal to 2 plus or minus I square root of 2. Again, this would be written as, we could write that as two answers, as 2 plus I squared of 2, and then 2 minus I square root of 2. But this would be our final answer as one set together. And our discriminant was negative. It told us that we were going to have two solutions, so the plus or minus, and they're going to be imaginary. That's where the I comes from. That's how we know we would have I in it. Example 2, we need to have this in standard form. Our A value is negative, which we don't really want to happen, so we want to actually change this. So if we actually move all of this to the other side of the equal sign, then we would have our A value positive. So let's do that. Let's put this into standard form with A being a positive. So if we add this over, we would have positive 3x squared. Then we would add that over, we'd have positive 8x. Then we would subtract the 16, and we'd have negative 16 is equal to 0. We could still have it equal to 0 on this side, or we could have 0 equal to that. It does not matter. It really means the same thing. So the reason we do that is so that A is positive. It's a lot easier to focus on, especially with the division of 2A. So now we have A is equal to a positive 3. B is equal to a positive 8. And C is equal to a negative 16. Plug it into our quadratic formula. X is equal to negative parentheses 8, close parentheses, plus or minus the square root of parentheses 8, parentheses squared, minus 4 parentheses 3 parentheses, parentheses negative 16, close parentheses. All of this is over 2 parentheses 3, close parentheses. So I'm going to fix the first part and then the denominator, and then we're going to find the discriminant in the calculator. So x is equal to a negative 8 plus or minus the square root of something, all over 2 times 3 is 6. So using the calculator, we're going to find the discriminant. It's, again, that without the square root symbol, it's just parentheses 8, parentheses squared, minus 4, parentheses 3, parentheses, parentheses, negative 16, parentheses. Our discriminant is 256. 256, if we take the square root of that real quick to see if it's a perfect square, it is a perfect square because it gives us a whole number. So that means that we will have two real rational answers. That means we will not have a radical left in our answer. So this is 256 right here. That's our discriminant. So we're going to rewrite this. This will be negative 8 plus or minus. We're going to have still all over 6. The square root of 256 was the 16th. So we have just all numbers. That means we need to simplify this completely. We're going to have two separated answers. So we have negative 8 plus 16 is a positive 8 divided by 6. So positive 8 divided by 6 is a positive 4 over 3. That is still a rational answer because it can be written as a fraction. Then x equals, we're going to have negative 8 minus 16 is a negative 24. Divided by a positive 6 is a negative 4. So our two solutions are positive 4/3 and a negative 4. Since they are real rational, we do separate them into two answers. If they are irrational or imaginary, we want to keep them as one set, but understand that these are still two different solutions. The plus or minus is what gives you your two different solutions. If we move on, number 3, we do not have it in standard form. We want to get it into standard form. We do have our p squared. That's the only quadratic term, and it is positive, so we want to keep this 12p squared on this side. So that part is good. So we have 12p squared. We want p, so our linear term, which is that 8p, means we have to subtract it over, so we have minus 8p. Then we want all of our constants over here, so we have to add the 2, so that becomes a negative 23 is equal to 0. Our a value is equal to a positive 12, b is equal to a negative 8, and c is equal to a negative 23. Now in this case, because we have the variable of p, instead of us saying x equals, it'll actually technically be p equals. So when I write the quadratic formula, because we're dealing with the variable of p, I'm going to use p equals. Still the same information, but I'm just putting the same variable we have. Negative parentheses, negative 8, close parentheses, plus or minus the square root of parentheses, negative 8 parentheses squared, minus 4 parentheses 12, close parentheses, negative 23, close parentheses. All of this is over 2 parentheses 12, close parentheses. Again, doing the same thing. We're going to have p equals, again, negative times negative 8 is a positive 8, plus or minus the square root of something. All over 2 times 12 is 24. We want to find our discriminant using our calculator. So our discriminant is that parentheses, negative 8, close parentheses, squared, minus 4, parentheses, 12, parentheses, negative 23, parentheses. And we get 1,168. Now let's see if that's going to be a perfect square. Square root of 1,168 gives us a decimal. Therefore, this is not a perfect square. It is positive, so we will have two real irrational solutions. That means we have to simplify this value. So 1,168 is our discriminant. That means that we will have one answer written at, it's going to be together, but we will have two solutions. So we can go ahead and write this as, draw an arrow out here. This is still 8 plus or minus, and it's going to be all over 24. Now we need to simplify square root of 1,168. So we're going to start 1,168 divided by 225. 1168 divided by, so 225, then 196. 1168, so that was 14. 13 squared. 12 squared is 144. 11 squared is 121. 10 squared we know is 100. We know that won't work. 9 squared is 81. 8 squared is 64. 7 squared is 49. 6 squared is 36. 5 squared is 25. 4 squared is 16. 16 works, but it's 73. Now, since 1168 was so much larger than 225, I could have started with a much larger, instead of 225, I could have started with something larger. So because I didn't start with the largest number that could be possible, so I have to see if 73 can simplify further. So we know we're going to have 16, so we know it's going to be 4. Right now it's 4 square root of 73, because square root of 16 is the 4, and 73 is still your radicand. So now I want to focus on the 73 to see if this will simplify further. 73 divided by, so I know if I go perfect squares, 8 squared is 64, 9 squared is 81. 81 is too big, so I got to start with 64. Does not work, so 73, so that was 8, 7 squared, 6 squared, 5 squared, 4 squared, 3 squared, 2 squared, and then 1 squared will just be 1. So that means that 73 cannot simplify. That means that this is actually as far as that radical will go. So now we just need to simplify everything else further. So I'm going to separate these into two different fractions. This is 8 over 24 plus or minus, this is 4 square root of 73 over 24. 8 over 24 is actually 1 over 3, plus or minus 4 over 24 is 1 over 6, and we keep the square root of 73. What that means is, because these do not have the same denominator, I cannot combine them as they are. However, you can actually put them back as one denominator. So this would be your answer, or you could put it back as one denominator by multiplying this by 2. And I'm actually going to write that as my answer. So I'm going to have P equals. If I combine this as one denominator, I would have it all over 6. I would have to multiply this by 2 and that by 2. So I would have 2 plus or minus. I wouldn't have to do anything to this, so it would just be 1 square root of 73, which is just the square root of 73. So I can actually have this as my answer. Either way, this could be an answer, or this one could be an answer. And again, this tells us still our two different answers. This would be 1 over 3 plus square root of 73 over 6. 1 over 3 minus the square root of 73 over 6. Those would be our two answers. Or we could write it as 2 plus the square root of 73 all over 6. And 2 minus the square root of 3 all over 6. So those would be your solutions. I just rewrote it so that we would have one denominator. This would be having two different denominators, which is the same value.